This project will explain about the application of physics concepts in fluid infusion. Firstly, the project focus question is, how can we transform the new world with the magic touch of physics? The big question is, why is rationality an essential skill for a visionary leader? This project ties in with the outcome, able to conclude solution of a physical case based on concept in fluid mechanics. This project will also be related to sustainable development goals of good health and well-being, as this project will help improve the health of people. In patients who depend on fluid therapy, maintaining a constant rate of infusion is essential for their outcome. The rate of infusion depends on the pressure in the infusion system relative to the pressure in the vein. When the pressure gradient is not enough to ensure a continuous flow, we need to increase the pressure in the infusion system. However, the vein is prone to kinking during infusion due to its position, which will increase the pressure in the vein. The hypothesis for this project is that in order to increase pressure in the infusion system during an infusion, there should be a device that generates pressure on the drip bottle. The concept of physics that is present here is the concept of pressure and Pascal's law. Pascal's law states that pressure applied to a fluid in a closed container is transmitted equally to every point of the fluid and the walls of the container. On the diagram on the left, the human it can be shown that the human blood circulation happening inside the heart, arteries, and veins in the body is essentially a large convoluted closed container. When it is connected to an infusion system by inserting an infusion needle into the vein, the infusion system and the vein become one closed container, and the pressure applied to either part of the container will either be transmitted to the vein and infusion system. Therefore, the pressure in one part of the system will affect and be transmitted to all other parts of the system. The flow of the infusion is dependent on two things: gravity and the pressure inside the system. Infusion fluid flows passively into the vein if the infusion bottle is situated higher than the vein and there is no resistance from pressure in the vein. However, sometimes we can find that the infusion bottle or syringe cannot be placed higher than the body, or there is added pressure in the vein. For example, when the vein is kinked, when the body part where it lies is bent. Or sometimes we might need a higher velocity of infusion than the free passive flow allows. During the research, an expert was interviewed about the topic, and a literature review was conducted by researching and reading publications on the topic in order to relate it with the chosen physics concepts. The solution to this problem utilizes a balloon pump, which when inflated, generates pressure on the drip bottle. Pascal's law comes into play here, and the pressure generated by the balloon pump will be transmitted to the vein, resulting in the flow of fluid. The vein will also have a sleeve around it and a splint beneath it to prevent it from kinking when bent. So based on the research findings on fluid infusions, our hypothesis was proven to be correct because fluid infusions rely on the pressure in the infusion system being higher than the pressure in the veins. The answer to the focus question is, using the touch of physics, we can apply physics concepts in our daily life and use them to solve everyday problems. And the answer to the big question is, rationality is essential for a visionary leader as it allows them to think realistically and set realistic goals while taking certain factors into consideration.